Light propagation.
And I can do it again. And what does this do for me? What's the purpose of?
Makes it take root.
Hmm?
Does it make it take root by holding it down?
Mm-hmm. I think I want to open the other one too. Push it back down. That's how we get most of our apple rootstocks too. If you're going to start an orchard, your plants are all going to be grafted, but you got to have your rootstocks coming from somewhere. And they don't do it like this, obviously, because an apple grows more upright like this. But they put them in stool beds, and they mound sawdust up over where the shoot keeps growing up. And the shoots that are coming out the sides, they keep getting sawdust mounted up over the top of them. Will then put off roots. You brush away the soil, and you've got all these side shoots, these lateral shoots that now have roots attached to them. You cut them off and you plant them. That's everything that we've had here. Last thing I guess I wanted to show you, we haven't talked briefly about rhizomes. Rhizomes and stolons are just both runners. Stolons are above ground. Rhizomes are just at ground level or underground. So the irises were rhizomes. These are rhizomatous. Liriope is rhizomatous. We've got other vegetative structures that are asexual propagation. Kelsey said, well, are those bulbs? Well, they're not bulbs, but we use bulbs for a couple of different ways for asexual propagation. These are, anyone know what callas look like? Calla lilies? Well, these were callas that I planted in my front flower bed, right by my front steps, and I decided I didn't want them there anymore. So I dug them up and I moved them elsewhere in my yard. But things get left behind, and this would have been two or 3 years ago that I moved out my big bulbs. But some of these little ones got left behind and became big bulbs. And big bulbs, you can see where this one is producing bulblets on the side. And this is a good illustration of how this is stem tissue, because you can see it's like stem tissue that's wound. And you can see the buds. You guys can see them, right? The buds that are right there that are appearing. And those buds are going to become little bulblets or not so little bulblets. It's not glued on there. It's actually attached to this mother bulb. And you can see, again, those little bulblets that are starting to form here. So callas are expensive. And once you, I guess the good thing is once you got them because you can't get rid of them. And then this is the fruit. And I don't know if they produce a viable seed or not, but even if they did, it wouldn't be as efficient as just separating out bulbs and bulblets. Another way we propagate from bulbs, hyacinth bulb. Hyacinth bulb looks something like this, and then it's got a basal plate, and that basal plate is stem tissue too. So it's all round. Well, if you turn it on its side. And here's that basal plate that's on the bottom. And you can come in and score or scoop out the bottom of this basal plate and discard it. You can't go in too far because you're getting into the leaf tissue up in the main part of the bulb. If you score out maybe between an 1/8 and a 1/4 inch of this basal plate, that injury to that stem tissue then causes the induction of bulblets all along there. Your book mentions corms. Corms are compacted stem tissue, and you don't really see them down here. Does anyone know what crocus look like? Crocus come out in the spring, early spring. Sometimes they push up through the snow. And where I'm from, everybody plants them because winter is black and white and dreary and drab and depressing. So the first taste you can get of color, since he's come up through the snow, you leap at it. Well, the roots of corms, what is it, crocus or gladiolas, you're more apt to see gladiolas down here, have what are called contractile roots. Any idea what contractile roots might do?
Contract.
And do what? Well, this one's going to send up its foliage and its little flowers. And the new corm, this one's going to be spent. This one's going to die at the expense of putting out vegetation and flowers. And the new one is going to form right here. Well, if that's your ground line, by the time this one, if it didn't have contractile roots, by the time this one stored enough carbohydrate then to bloom and form a new one here, and then by the time it stored enough carbohydrate to produce a flower, in no time at all, your plant is where? On the surface. By virtue of having contractile roots, this one's going to die. So it'll just kind of wither away. And these contractile roots are going to pull this corm back down to this area, pull it down into the soil so that it stays at the depth it's supposed to stay at. But corms produce cormels. Cormels, and that's how they vegetatively or asexually propagate. Are there any other, can't think, are there any other structures that they talk about in your book? Tubers and tuberous roots, you know what tubers are. Obviously the most famous tubers, the